this is IBM Museum. And even compared to that prior video where it was just hasty, I went through and generated a diskette on the Mall 30, actually a couple diskettes, just so I'd have a backup copy, plan B as it were, if I have one diskette that doesn't work. And then I moved the Mall 30 and put this server 320 up on the bench. And today I'm even doing less preparation. I went through and I moved the PC server 320 down to the bottom here. It's actually underneath the front keyboard, and then put the Mall 30 back up there and connected it up. And I didn't even, we're going to do all the diskette copies and everything else that we need to do. I've got the Mall 30 running right now and do not have the PC server 320 on, of course, because it's only able to boot from that diskette. We're going through and making up the diskettes, just copying files over. So I'm going to get flipped around. And I even have some needle nose pliers, because it took that to get the diskette out of the drive for the PC 320. I've got the door open here, and I realize that people can't see the front of the unit or anything else, but once I get the diskette, I'll just put it down and I can switch over to the video capture, which is connected to this unit. As I say, the Mall 30 is actually behind the bench here. And I started up and I even went through and I loaded the mouse driver. I want to actually copy over the mouse driver, and it's actually this back. In fact, actually, let's go through and let's do a directory. And I have one of the boot diskettes that D is giving me a hard time. With that space saver keyboard actually connected up to the Mall 30 in this case. And I just want to make sure we've got over a megabyte of free space. So we're doing good there. I'm going to do a copy of the mouse driver. Not sure why space. I'm just doing copy mouse.com to A. I know that the mouse.com is actually in the root directory of the Mall 30 here. And I don't know when I put that on the Mall 30, but it's probably a good thing if we're running the code view. And otherwise, you know, the code view, I have the original diskette in the B drive for the code view. And so I know that that's 360 KB. I mean, that's all going to fit all the files that are on there, and that's the code view for MS-DOS. So we're just going to do a copy B, and then just a dit dot dit, and I actually should be imaging these original diskettes that I have, just so I'm not going through and using them. I mean, I've got enough blank diskettes, certainly. And I'm just going through and being a little bit quiet you can hear the clicks of the 5 1/4 inch drive. And I don't know what some of the aspects are, because this should just be the code view files, I think, that are on that diskette. And it's even supposed to have the help files and things like that. That cb.hlp. I realize that text on that monitor back there can be a little bit hard to read. I thought it was about that many files that were on the, and I've actually got the code view directory set up on this. In fact, that's probably what I'll do for the other diskette, just to show how that can be probably a little bit faster than accessing this 5 1/4 inch drive. Okay, 15 files copied. So, as I say, actually what we'll do, we'll go through and we'll pull that diskette out. And this ejects good from the MOL30. But on this next one, to copy the same files, let's go through and do a copy and just giving it the, again with the D. Okay, to the A drive. And quite a bit quicker. Okay, and we'll also copy that on the right keyboard. I was getting prepared for using the PC Server 320. So we've got the 2 diskettes now. And, we can just leave the MOL30 idling here. Or even go through, and still hard putting the diskette in the drive. And it just is where it's like the alignment or something else. Wow, that is really being a challenge. It was heck. Getting it out of here, and it's going to give me some grief getting it back in. I'm going to go through and I'll cycle off even though there's not really any worry for me, I'll go through and I'll cycle off the mul 30, and we'll get this actually over to my other system here. And I'm going to go through and I'll need to work with, okay, there we go. Yeah, that thing, I'm going to have to look at it and figure out why it's having such an issue. And I do have I even have a CMOS battery for this and a screwdriver to go through and to get into it. And so what I'll do is I'll get the screen capture going. That diskette is all the way in there. And it didn't shift. And of course, since there's such a long boot up time, we got that CMOS error again, but just the same way. And we still have some defunct drives that are in the mix. We're just going to gloss through. And the arrows are supposed to denote what the system figures has changed. Okay, boop, boop, beep. And I need to make sure I never heard anything. Okay, I've got my Google Assistant responding, but I've never heard anything saying the mic was muted or anything like that, at least when I was tipping my head. And I'm aware that that can sometimes happen. So I just have to make sure that my audio levels are good. And we're not going to go through the big long post here. We're just going to press escape. Now, it's important to note that I didn't change that dual bus program at all. And I'll get through and modify that later, of course, and shorten it. And an interesting aside from the prior video is Major Tom went through and commented that really the only dual bus system that he's aware of or that reports a dual bus is the IBM Industrial, and it's called the Gearbox. It's a 7552, and I need to actually get my 7552 back working. It's got a power supply issue, and go through and test that. And some of the routines here for the microchannel, because the 7552 isn't really necessarily a fully implemented microchannel, and there's a lot of history that we may have to go in to explain some things because of how IBM released that. Because as we have in the code, it goes through and it checks the submodel as well, and the gearbox has a submodel of 6, which kind of gets interesting because for the Model 50 and Model 60, which are fully microchannel, implemented all the way just like IBM did later on, those have a lower model number, 04 for the Model 50 and 50Z, and 05 for the Model 60. And so those submodels were actually defined before a submodel was defined for the gearbox. And it's almost like IBM had the design done, and then thought, well, we've got it in this form. We might as well go through and release it with whatever BIOS level and however we did the microchannel. And truly, the ISA interposers, I'll give a link to those and show to that page at the Arden tool and show what the interposers are. And that's how it adapted for the bus type, whether it's microchannel or ISA. And I think the industrial, I mean, I've got spare of those ISA interposers, but I'm wanting to get actually the microchannel versions and go through and run them. I don't think the gearbox itself, the 7552, was necessarily released with the microchannel ones. I think it was just ISA, and so the places that bought those were able to use the unit fine without entering into the microchannel world. So I mean, that's just a guess. But let me get through to the code. Remember we went through and in fact, let's go through and we've got the edit. In fact, what we'll do here first, let's just load the mouse driver. And then let's go through and do an edit for the check error .bat. Remember, we got to put the full extension on the end of that. Okay. So we have it run through that check MCA routine and then the dual bus. And we did have the check MCA routine running fine, reporting back correctly. And then the dual bus aspect was not doing anything. So we're going to do an Alt F exit. We didn't change anything. And we'll do just running that batch file. And it's just reporting that it's microchannel. So what we actually want to do here is we'll do the code view, and we're going to do it on the, for this one, I just had it as dualbus.com. And because we have that assembled from that previous video, and we're wanting mainly to see, or just to have the system run through the program. In fact, I'll go through, I'm going to hide myself because I've got to go through and also put up the, we've got the mouse. Okay. And we're going to do a view because we want to do the registers over on the right-hand side, just so we can see where that system descriptor table will be. It'll give an address for the start of that. And so really going through, this is going to be probably very brief as it goes through and tests this. It runs this test byte pointer for that in the system descriptor table for that first bit position, the least significant bit in that feature byte 1. And it's got to go through, and of course it steps into the BIOS routine, all that F segment stuff. And wow, that goes through quite a bit. Okay. So that's come back to my code now and terminated normally. And you notice in the over on the right on the registers, we're looking at, I'd put myself back on screen. I guess well, that's probably easier for me to describe. So if we look over here, at least I've got the mouse pointer to kind of highlight things basically. And so we're looking at that ES value. And that on the return from interrupt 15 function C0 returns the, that's a segment for the system descriptor table. And of course, as 000 being in the system BIOS. That table is at a location in the BIOS. And we see up here for the BX, we see this the C4 E5. So the system descriptor table is at F000 colon C4 E5. C4 E5. Remember that. So what we're going to do is we're actually going to exit out of the code view program. We're going to start up debug, which you already had on this boot diskette. Okay. We're going to do a dump. And we're going to do an FFF. And I've already forgotten my good old memory, right? C4 E5. In fact, let's do just a C4 E0. E5. Okay. So we see a little bit, and it's 9 bytes. Okay, so I'm going to do a length B. So let's do a dump. In other words, it's displaying more than I'm wanting to do. I'm just going to cut this down to a length of B, which will give our full system descriptor table. Okay. And I have to see how that's showing on the screen. And so it starts out, in fact, that's probably a good point for me to get let me get back on the screen here. Okay. And so what I can do is I'm going to bring up in fact, I need to even see what I have for the browser capture. Okay. Yeah, I'm going to need to change that. So I'll be right back. Okay, and I just went through to also just pressing the enter key several times, get the information that we're looking up a little bit more towards the middle of the screen. And in the okay, so, and I'm probably still fine here being on the screen. Let's interact with things. And so we're going through, and in fact, I'll find out. I can probably go through and just toggle between. So first off, we're looking for this at the offset 00 hex. We have number of bytes following, and that's a word value. Going through, we have that represented here. That word value is ultimately 0009, working with those first 2 bytes because it has least significant byte first and most significant byte second. So those are inverted, or it's a little Indian storage notation. And hopefully Major Tom won't need to correct me from that. I'm going through, and we'll see how many times I stumble here. So it's effectively 9 bytes that are following that for the detail. And that's why I went through and did the length B to get all the items that were there. And if we remember, we have that the next byte over, that F8, is ultimately the model number. And it's that loose IBM convention that if it's a 386, and that pertains to an SX or 386DX, if it's a 386 or higher, it's an F8 model. So there's quite a few models, of course, that are denoted by the F8. If it's anything that's a 386SX, a 386DX, or higher, 46 Pentium level, whatever, it's an F8 in IBM nomenclature. And so scrolling the next range there, and since it doesn't have a lot of delineation for the model, it's going to be the submodel. It's going to be the next byte value. And so that comes to be 3B. And that's, of course, expressed in hexadecimal notation in debug. But apparently the 3B is the BIOS submodel for the 520, 320 PC server. We'll have to even see what range that goes in. I do have the ESIA models that I'll go through and test at a later point. We can look at what the submodel is for those. And so we get the submodel and the BIOS model and submodel. And then the next byte over is 02, okay, which is the BIOS revision. And remember, this is a flash-based BIOS that we're talking about now, and I think I'm up to 29. I don't know what it said on the paper. 29A. Yeah, 29A BIOS, but it's being classified here as the BIOS revision 2. And then, so the next byte is that feature byte 1 that we're really kind of interested in. In particular, those low order bits, bit 1 and bit 0. Bit 0 being for the dual bus, bit 1 denoting for the microchannel side. So let's go through, hide the browser capture window again. In fact, I even have to move the interact screen here for my browser capture aside. And so that is 76 hexadecimal. And 7 is for those first 4 bits. We get to the point of where that is the DMA channel 3 used by hard disk BIOS. That's not set in this case. That would be for that first nibble of that byte in those 4 bits. That would be the only bit that's effectively off or cleared. And so what we're effectively seeing in bit 7 is 0. Bit 6 is a 1. The second 8259 PIC installed. Bit 5, real-time clock installed, is also set. And then bit 4 is that interrupt 15 function 4F called upon interrupt 09 hex. And then we get to the low order bits, bit 3, bit 2, bit 1, bit 0. And it was a 6, in there. Yeah, 6. So what we're seeing ultimately is that the bit 3 interrupt 15 hex function C8 enable disable CPU functions supported, excuse me, is ultimately cleared, is what that seems to be. And then we get to bit 2. Okay, excuse me, I was looking, in fact, I need to scroll that down. Okay, so just to get my webcam view out of the way. Okay, so excuse me, so wait for an external event is that interrupt 15 function 41 hex supported. That bit is clear for feature byte 1 is what we're working on. The bit 2 extended BIOS data area allocated, that's true, and that bit is set. And then also bit 1 bus is microchannel, that is set. That's what we're getting on return. But that dual bus system is cleared. So on that lower 4 bits, bit 3 is cleared, bit 2 is set, bit 1 is set, and bit 0 is cleared for the value of 6. So in the system descriptor table, this PC server 320 that thinks it's a server 520 doesn't have that dual bus bit set to report that. Now, if we wanted to look down through, we're there, we might as well go through and kind of look. Moving on to the feature byte 2. Okay, and I'll have to look at, so we've got FC. So this will be fairly easy for this next one. The first, for feature byte 2, bit 7 is set, bit 6 is set, bit 5 is set, bit 4 is set. So we have that 32-bit DMA supported, and the 3 references to the interrupt 16 hex function 09 hex, interrupt 15 hex function C6 hex that get POS data, and that's a microchannel function. And then that interrupt 15 hex function C7 return memory map info. All that is supported for the PC server 320 because it has that hexadecimal F, meaning all 4 of those bits, those high order bits, are set. For the C value, that means the 2 most significant bits, bit 3 and bit 2, are set, and bit 1 and bit 0 are cleared. So this is showing a interrupt 15 hex function C8 is supported, that enable disable CPU functions. And then and that's probably cache control ultimately, L1 cache control on the CPUs. And then the bit 2 is non 8042 keyboard controller, that being set. And yeah, most definitely that's integrated into those chips and the support chips. And then bit 1 data streaming supported is cleared in this case, and bit 0 being reserved, and that's also cleared. And it's interesting for the data streaming supported. I mean, we're going a little bit further than the dual bus stuff now, but might as well. And I know Major Tom will be interested in this, and there's a lot of probing that we still need to do. So this, in fact, I'll get through. Let's get switched back there. Okay. Get myself off the screen. Excuse me, I have to hide the browser capture. I'll hide my webcam just to make sure I've got the full field of view for the planar I used in the example in the prior video. And Bill Bus, there's just 2 PCI slots there. Really not all that much. And as I explained with this, where you had microchannel and then you had PCI, well, if you had a server, what you do later on is microchannel did not have really any network controller, Ethernet or token ring that would get up close to that the 100 megabit speed. You had a lot of for Ethernet, you had a lot of 10 megabit per second, and for token ring, maxing out at 16 megabit per second. So you actually put, a network adapter into a PCI slot just to get better network performance off the PC server. But for the data streaming, I want to show this right side up too, and I may have to. I'm sure Major Tom probably knew that of the diagram. But look at that chip. That's a 06H5685 ESD. I'm sure Major Tom can tell us all about that. I don't know I don't really know the synchro stream stuff right off the top of my head either. But I thought I'd kind of show that, and maybe he's interested in that for that aspect that it says that the that data streaming supported, that bit 1 is ultimately cleared. Just getting my scene shifted around here again. Okay, get myself back on the screen. So it's saying there, data streaming is not supported on the PC server 320 or 520, the microchannel board. So that, I don't know what can be determined from that. Now, getting down to feature byte 3, a lot of it's reserved there. In fact, let's get through to get out of the browser capture. Moving around things once again. Let me get that over there, probably is a good place. So that's got 3, 1, 3 being the that high nibble, and 1 being the low nibble. And so that is fairly easy to decode as well. Here we have, anyway, the for bit 7, bit 6, bit 5, bit 4 of that feature byte 3 that we're moved on to now, 3 being that bit 5 is set, which is marked as reserved here. So there's ultimately some function that's basically hidden from us that IBM just marked that as reserved. We've got to figure out what that may mean for the system descriptor table. And then bit 4 post supports ROM to RAM enable disable. That's also set for bit 4. The other reserve bits, otherwise for bit 7, bit 6, are cleared. When we get down to bit 3, bit 2, bit 1, bit 0, that's the low order, or the low nibble of that byte, being 1, the value of 1. It's only the last bit 0 that actually has the that's set in this instance. It's not an IML system. There's no info panel installed, and the SCSI subsystem support on system board, which is kind of interesting for all that, because the PC server 320 and 520, they have that SCSI subsystem on the system board. So that's kind of strange as well. It's I just don't know what we're seeing, different information here. IBM didn't mark it as a dual bus, and they didn't mark it as having a SCSI subsystem on the system board for some reason. They went through for, that information panel is not installed. That's correct. IML, it's not an IML system. And then SCSI supported in IML is that bit 0, and that is set. And so that really has to be, it almost seems it's backwards for that indication that the SCSI supported in IML, yet it doesn't have marked for a SCSI subsystem. I don't know. We're just probing. We're just playing along now. We're just kicking up dirt, seeing what the system descriptor table is reporting. And really going through, grabbing go through and this has that SCSI subsystem on the system board. There's the 50-pin connector, and then we've got those 68-pin connectors. And these are, one of these is actually patched through to the back of the case for the external SCSI, and then the other one is used for the fast-wide internal otherwise, and then you have the narrow SCSI for that 50-pin connector. But there is SCSI on system board. So I can't wait for Major Tom to see this and weigh in on that, as well as the data streaming stuff. That just that seems a little bit off. Besides the dual bus and everything else, do we want to get into feature byte 4? Well, we can. And I'll need to get shifted back to where we can see that reported value for the system descriptor table. Again, get myself back up on the screen. Get that hidden away. Get this moved around. So the next byte, feature byte 4, is that 5.8 value. And going through to feature byte 4, let's do a little bit of scrolling, get that fully up. And so we had, again, my short little memory, 5.8. Okay. So 5 is alternating, kind of just like the reverse of A in hexadecimal. It's 0, 1, 0, 1. Bit 7 is marked as unknown, and that is cleared. Bit 6 is system has EEPROM, and that is set, and that's ultimately true. I mean, it's a flash-based BIOS. Bit 5 and 4 are part of a composition of a 3-bit, and this is kind of interesting because it's in both, nibbles for this little sub table, as it were. And we do have bit 5 is ultimately cleared. Bit 4 is set. And then for bit 3, we have to look at that low order nibble of 8. And indeed, 8, as it is, would go through and be bit 3 would be set. So we have 0, 1, 1 for that table. And so we have ultimately that decodes into a BIOS in RAM is the meaning of the bits 5, 4, and 3. And then for the bit 2, bit 1, bit 0 of that low order nibble, those are all cleared. So bit 2 marked as reserve is cleared. System supports memory split at above 16 megabyte is cleared. Post X directly supported by post, whatever that means, that is also cleared as well. So, we're saying just that basically for that feature byte 4 that the system has an EEPROM, ultimately a flash BIOS, and that a BIOS is in RAM for the way that table looks like it's decoded of the 3 bits. Now for feature byte 5, and it's showing me, I don't know why there's a difference. It's showing me I'm scrolled as much as I can in OBS, but then it is not. Yeah, that's not. It's not adjusting. Oh, okay, there we go for. I don't know why that's overflowing. I'm just trying to get that featured byte. Yeah, and that's effectively okay. So that'll work to get us with the feature byte 5 at the bottom. So really for feature byte 5, a lot of the high order bits there are set as reserved. Let's look at what our system reports. Okay. So there's ultimately that 2B. 1, 2, 3, 4. Yeah, I'm just going through and counting. I've kept pretty good track of things. So for that 2B, it is ultimately, let's bring up the, okay, so 2. So for bit 7, 6, 5, and 4, we have that nibble of 2. So bit 5 being reserved is set. Bit 4 marked as reserved is set. And then, of course, the high order bits, the bit, let's give me, okay, I didn't do my good decoding. Bit 5 reserved is set. Bit 4 for marking as reserved is actually clear, just the same as bit 7 and bit 6. So only bit 5 is set on that high order nibble, and that's a reserved marking from IBM, or that the coding is not known for that. And then for the bit 3, bit 2, bit 1, bit 0 being the low order nibble of that byte. For C, it is, so for C, it should go through, okay, so A is alternating. So we ultimately have for B, it'd be bit 3 is set. That's a reserved indication. Bit 2 is would ultimately be cleared in this case for that reserved. And then we would have where bit 1 system has enhanced mouse mode, that would be set. And then bit 0 flash BIOS would be also set in that. B would be is effectively one more than A, so that goes through where it's bit 3 is set, bit 2 is cleared, bit 1 is set, and bit 0 is set. Going through and trying to keep my hexadecimal references going. So we've seen what the system descriptor table is showing for that. And this video, I mean, it can be paused and going through. We're ultimately trying to do a, and of course we want to really decode what these reserve bits and other things are, two things, but this is going through and just all the investigation that we do. That's where that system descriptor table is. And we've seen that it's not marked for a dual bus, but then it's not marked for a SCSI subsystem on the system board, and it's not marked for data streaming being supported, which is interesting with that synchro stream chip that's there. And who knows with the other angles of that. I'll go through and I'll list that in the links to those pages, of course, in the video description. For one, the interrupt that we're looking at, or the function, the BIOS function that retrieves that system descriptor table, interrupt 15 hex, function C0 hex. And then I'll also give a link to the 320 and 520 microchannel page again. It's got that, it has that diagram and the component identification on the system board. And I likely have all the combinations of that, of the planers or the system boards that went into the PC server 320 and 520. As we've seen on this system, this is probably where I swapped it from a 520 unit prior and put it into this 320. Probably is the top end board. But I'll go through and I also mean to get pictures going. That photo rig I have off to the left, I've still got things in kind of a convoluted manner. And I'm going to go through and I've moved some other stuff in the studio, and I've got to go through and get a light box set up for it. I'll get that display off somewhere else. I've got to get the display for this back panel off on the bench itself too, and just clear that thing out for doing my photos. It's a photo rig, and I'll just have to come up with other places to put things. I know that's been kind of the side section where I put the tweener system and everything else, but this is how, I just have to adapt and get a good light box so I can start doing a little bit better pictures. There's been imperfections in some of the stuff I've taken recently. I can't depend on the room, the lighting of the room in the daytime and how it plays across some of the components or anything like that. So there's some adjustments I'll do for that. But if you thought all this rambling on, and I mean, we did have a topic of focus here in looking at things. We learned where that system descriptor table is in the BIOS, and we learned how there's just some strange things that are set there that are reported that kind of makes you wonder in a way. And we learned the BIOS model and BIOS. I mean, that the BIOS model is no question. It's got higher than 386SX or 386DX CPU. But we learned the submodel as well. We learned the BIOS revision that's reporting and things like that in that system descriptor table. So it was quite a bit of that we did of information that we did gain, and we'll go further than this even as it is. We'll go through and delve in deeper. And as I say, I can't even wait for Major Tom to look things over and weigh in and what comments he's going to make on the things that are reported here. But if you enjoyed the video, go ahead and click on the like button, of course, and subscribe to my channel if you've not done so already. But this is IBM Museum. That's all I have for now. Thank you.